So following on from some of the earlier videos, we were trying to sketch this function here, and we got to this stage where we know the graph will do something like this. It passes through 1, and then it's going to, as x tends towards positive infinity, it will head towards 0. So it could either do this, heads towards 0, or it could do something like this, go down and then heads towards 0. Okay, but then with version 2 here, so don't forget version 1, it could do something like this. With version 1 here, just bear in mind that with version 1, f prime equals 0 in only one place, which is this place here. With version 2, we will have two places where f prime equals 0 here. So with version 2, f prime here should equal 0 here, and f prime should equal 0 here. So with version 2, there are two places. Version 1, only one place. Okay. But anyway, we will need to differentiate this. So differentiate it. Find out where the gradient will be 0. So our next step is to differentiate this. So rewrite this thing here as one thing times another. Let's just switch these two around so it looks more natural. So you've got this times this. Okay, not important, but well, it's up to you. So now differentiate this. So here you've got one block multiplying another block. So you've got to use the product rule, and the product rule is differentiate this, leave this the same, and then leave this the same, differentiate this. Okay, so the product rule is differentiate this, blah blah blah, and then f prime equals this thing here. Okay, so f prime equals this thing here. So you've got to say to yourself, when will the gradient of the graph be 0? The gradient of the graph will be 0. So let's make this to be 0. So once you're here, you've got to ask yourself, when will the gradient be 0? The gradient will be 0 is when you try and solve this bit here. Okay, so imagine this as being one thing dividing by another thing, times both sides by this thing here. That will then be this, and then add natural log to both sides. That will then give you this, and then exponentiate both sides here. So e equally to both sides here. So that will then give you this. These two will cancel each other out, giving you this. So x equals e squared. So you see, when you put e squared into this thing here, into this thing here, when you put e squared into this thing here, then the gradient will be 0. And the thing is, there's only one place where the gradient is 0. So that means that we can only follow version 1, which was up here, and then up here. So earlier we had a choice of doing this or doing this, where it goes down and then heads towards 0 here. But in this case, because we know the derivative equals 0 in only one place, then it must go over here and dip down. Because by doing this, you only have one place where the derivative is 0. The version 2, you will have two places. You have here and here. Well, anyway, it's going to do this. Okay, but the thing is, at x equals e squared, that's when the turning point occurs. See, the gradient here is 0 now, and then it will head towards towards 0. Okay. So we know that the gradient here at e squared. We know the gradient would be 0 at e squared. So now we want to find out how high this value will be. So let's put the e squared into here and into here. Okay, so that will then give us the y value at that point there. So put it in. So basically, it's us evaluating this. So when you evaluate this, it gives you this. So we know that the turning point is right at e squared, comma 2 over e. Okay, so the turning point will be like this. Okay, so now we've got to consider the intervals now. So let's consider the intervals in between this region here and then in this region here. So in this region here, looking at our graph, it should be positive over here. Looking at our graph, and then here it should be negative. Okay, so meaning that whenever you have f prime being positive, it means that the original graph, which is this thing here, the original function, will always be climbing. So it should be climbing, 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 climbing. And then here, if you have f prime being a negative, then the original graph, the original function should be falling, 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 falling. Okay, so let's double check this. So in this region here, let's try and look at the f prime in this region here. So hang on. This here is our original formula for this here is our f prime. Okay. Now we've got to think about what happens when x is in this realm here. So so hang on. This here was our f prime, but this thing here is really hard to understand what's going on here. So we're just going to visualize it like this. We've got x to the power of half times x to the power of 1. We're going to visualize this thing here as this thing here because we don't really understand what it means to have a power of 3 over 2. So let's just imagine it as this here. So in the region of x being greater than 0 but less than x squared, you see, when you put when you put e squared into here, this thing here will be hang on, let me think. In this region here, this whole thing here will be greater than 2. It will be greater than 2 because if you think about it, if you you might have to press the video and have a think about this because if you put this into here, this here will be, well, think about it. This whole thing here will be greater than 2. Okay, and then in the region and where x is between here and here, this, don't forget the graph for this here looks like this. Square root of x looks like that. So it will always be positive. So so this thing here will be positive. Okay, and then this thing here, y equals x, will look like this. When x is in this region here, this thing here will also be positive. The number 2 is always positive. So overall, this thing here will be positive. Okay, and now consider in the region where x is greater than e squared here. So our original prime f prime of x is this. Visualize it. Visualize this thing here as this times this times this. You see, when x is greater than e squared here, this thing here will be greater than 2, will be bigger than 2. Now you've got 2, take away a number that's bigger than 2, then overall this here will be a negative number. So this here will be because if you think about it, if looking at this here, if you put a number that's greater than e squared, then this thing here will be bigger than 2. Now 2, take away a number that's bigger than 2, that means this whole thing here will be a negative. So that would be a negative here over a positive, okay, because all these would be positive. So so overall f prime in that region will be negative, meaning that if you look at our graph here, so basically we've just verified that f prime, we've just verified that f prime in this region here will be greater than this, and f prime here is less than 0. So that means it's climbing, 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 and we verified it here, falling, 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 and it verifies. And we've verified it here. And you should also double check, try and detect points of inflection. So try to detect inflection points. So you've got to differentiate, find f double prime. I'm running out of time, so I won't be doing this. Okay, but try to detect points of inflection. There might be a point of inflection somewhere around here. I don't know, but you got to do it yourself. Okay, because I'm running out of time. Sorry.